of step 10, this is going to become the new P site. This is going to become the new E site. And there's going to be a spot here that's the new A. What happens to the tRNA sitting in E? It leaves. If I attached my amino acids to the guy sitting in P, my amino acids would leave with my tRNA. Does that make sense, the picture? Okay. So, the reaction that actually happens, which is catalyzed by our RNA, attaches them this way. Does that make sense? So the reaction that happens, which is catalyzed by the ribosomal RNA in the large subunit, transfers the methionine from the P site to the amino acid tryptophan sitting in the A site. So even though the peptide bond is being formed in the P site, it actually ends up in the A site. But remember, this whole thing is happening down the line of the choo-choo train. So really, you're now in the new P site. Am I making sense? And what's going to happen next, make sure I'm not missing a step. Did I miss a protein? I missed a protein, I'm sorry. An important protein. Elongation factor. This is what allows for that guy to bind to the codon. Sorry. Yes. Right.
What's function?
It helps the tRNA bind to the codon. Yes.
It brings its own GTP as well.
It does. It cleaves GTP. All of this stuff cleaves GTP, and that's the energy that's used to deal with all the things. So it brings in a GTP, which is going to be cleaved later in the cycle.
Sorry.
Step 10.
Okay.
Do you have any what?
In order to bring the tRNA in, you need to have another factor called elongation factor 1A. Then you proofread. Then you have your ribosomal reaction.
So 2A brings in the initial one to finally find the AUG. 1A brings in all the successive.
Those are initiation factors. This is an elongation factor.
Oh.
Not IF, EF. We're in elongation. It is. Pay attention to those E's and I's. They trip you up. All right. So step 10, we made our reaction. In order for this whole thing to be moving down the line, like I keep saying it's moving, it's actually done because of GTP hydrolysis.
Can you say that last part again?
In order for this whole ribosomal subunit, yes. One second. In order for this whole ribosomal subunit to slide down the line, some GTP is hydrolyzed. Yes.
So it's just the bumps the amino acid and all down the line.
Not entirely, because the actual reaction that is the hydrolysis reaction between these two guys up here, if you remember, or not hydrolysis, dehydration synthesis that occurs up here actually releases some energy that helps as well.
So the whole idea of A, B, B, E, E leaves, that isn't step 10 dollars, or that is part of step?
That's part of step 10. Yes. It's kind of both. The ribosomes are moving and so is the RNA, and they kind of like do like this. Does that make sense? So the ribosomes are moving one way to translate, and the mRNA is moving the other way so you can continue to go. Does that make sense? Greg, you're looking at me. Yes. Oh, okay. Yes.
So each charged tRNA binds the GTP, and that is what's cleaved.
Along with the rRNA inside of the ribosome. That's going to be what actually, the rRNA is what's going to be what connects the two amino acids, and that cleaving of the GTP helps with the sliding. Yes?
Is the elongation factor another GTPase?
All right. This happens over and over and over again. And over and over and over again in elongation. Okay? That is what we are going to call step 11. Repeat steps 8 through 10 with correct AA, amino acid. Yes? Okay, so as this is happening, you're moving down the chain. So what I'm going to do is step 11, I'm going to use color. All right, so if I'm repeating steps 8 through 10, you would then have this be E, P, A. And then you would go E, P, A. And this whole ribosomal subunit is moving down over and over again. Does that make sense? Each time this guy is sitting here and he's no longer charged, he exits at the exit zone. Which I don't think I have. Each time somebody is sitting in the exit zone, the E, they're going to leave. They're no longer, there's no reason to be bound anymore. All right. Yes.
So the ribosomal subunit is the one moving along the RNA, not the RNA moving through the ribosome.
It's both. So here's the ribosome and here's the mRNA. The ribosome is moving down the way and the mRNA is kind of moving this way. Does that make sense? So they're kind of both moving. Yes. But they stop every 3 to do this process for 1 second and then keep moving. It's however you can move to make it happen as fast as possible for stabilization purposes. Yes.
So 8 is the binding of the tRNA's codon, 9 is the proofreading, 10 is the shifting, and then 11 is repeat process of all 3 over and over.
Yes.
Okay.
But don't forget that in 10, you also have the reaction happening. Plus the reaction binding your 2 amino acids. This thing right here. Yes, Felicia.
Okay, so the reaction takes place on the A site, although P shifts over to replace it, I guess.
Technically, the tRNA is sitting in the P site, along with the ribosomal RNA attack, for chemical terms, attack the amino acids sitting in the A site. So it's catalyzed in the P area, but they end up in the A, and at that moment, everybody shifts downward 3 codons and moves to the new sites. It's kind of like there's some good YouTube videos I may post for you all to actually see it. It may help. All right. Oh, I went too fast. Step 12. When you reach a stop codon, like right here, Your whole ribosome is technically shifted. To stop it, you have release factor that binds. This catalyzes the whole reaction to end the process. Yes.
Do we need to know the elongation factor here?
So release factor binds calories whole reaction.
And it releases it. So instead of letting a tRNA bind there, releasing factor binds there, which tells the whole kit and caboodle to stop. The reaction the P site tries to attack the A site, but it's release factor, which then tells the polypeptide to go do its thing. Okay? Yes.
So instead of tRNA binding, or
Release factor binds. It kicks everybody out. Yes.
By everybody, you mean?
The whole polypeptide chain. We're in amino acid land now. The ribosome will disassemble and be reused again. So we don't want to waste all those hard work, those hardly made things. Proteins and RNAs. Yes? Release factor. All right.
On step 10, whenever the charged tRNA, we bind it to the GTP.
So GTP is hydrolyzed in here by EF1A. This whole process here is separate.